Good morning. Today I'll teach. Let's write programs performing addition and subtraction on single bytes, double bytes, and multi bytes addition. Programs on addition and subtraction. Operands are or maybe single bytes, double bytes, and multiple multi-byte. So on these operands, we are going to perform addition, addition and subtraction instruction. In that, the first one is problem is addition of two 8-bit numbers. Addition of two 8-bit numbers. Here the question is write a program to add two 8-bit numbers. First one is 14H and 23H. Store the results. Addition of these two 8-bit results. This sum will be stored in 8500 location. It's very simple. Now I'll write. See, flowchart is very simple. Why? Because we need to load. We require two registers. While performing addition operations or any arithmetic operations, accumulator is always destination. Therefore, we require another register to perform additions. So, arithmetic operations on register is not possible. So that's why one of the registers should be accumulator and another will take any register out of 32 registers. So first one is flowchart. What could be the flowchart? Flowchart means first we need to load 14H into the accumulators and 23H into any one of the registers. Let us assume or not. Stored or not. Now addition, add 14 and 23. So therefore add A comma or not. So addition will be performed. After addition, results will be stored in 8500H location. And end. These are the simple steps of flowchart of this particular. Say I'll write a program now. First, what should be move? We need to load this 14H into one of the register. First, I'll take accumulator. Move 14. This immediate addressing mode. Immediate data will be sent to the accumulator 14H. Next, move R0, comma hash 23H. So we can send this data to R0. Now add A comma R0, and these two will get into R0, and these two addition will take 14 and 23 plus 23 addition will get 7 and 3. 37 is a result, and this sum will be again stored in accumulator. So what this add A comma R0, the contents of A added to the contents of R0. The contents of R0 is added to the accumulator content, and result will be stored in accumulator again. So the contents of accumulator will be modified, but the contents of R0 register is not modified. Why? Because it's 23. After this execution of this instruction is also R0 is equal to 23. Next result is over. Addition is over. After addition, we need to transfer that these results into 8500 locations. So therefore, we require a pointer. Move dptr. Which location should point out 8500 H location. Now, move. We need to send external transfer. Move x, where the source contents will be present in some results will be present in accumulator. So therefore, accumulator acts like a source. And where should be, so these are dptr, where the dptr shows at the rate dptr. So now the contents of accumulator will move to the address location whose address location is pointed by dptr. So that is 8500 H location. After this, stop or end. And also we can write otherwise as jump here only. S jump, unconditional jump here. And here itself is label address will be given. Here continuously infinite loop will be formed. So therefore, program does not proceed further. The same problem can also be written like this. Here this move a comma hash 14H. Right. Now directly we can write add a comma hash 23H. So no need to, this 23H is no need to send another register. Why? Because we have an instruction in addition, add a comma immediate data. Already we sent immediate data to the accumulator. Now accumulator consisting of 14H and 14 plus 23 will be added together here itself. So that is equal to 37. Again 37, this 37 is updated in accumulator. Now directly this move dptr comma should point out the location which we need to, which we have to send the data results to the external memory locations. Now we need send external means, so therefore move x at the rate of dptr comma create a consistent. Same both these programs will and performs this addition operations over 8-bit. Over 8-bit. Program is, the second one is, let me link my digital notebook. The second program is here. This is the second program. Here, write a program to perform two 8-bit numbers which are stored in external memory locations. See here, what this is in second program. Here I will write here 8500 is there, and 8501, 8502 is there, and 8503. This is the memory locations, external memory locations. These are the external memory locations where we need to save the data. So let us take here content 13 is there, here 14 is there, and these 13, these two are 8-bit numbers present in 8000 locations. 8051 14 is present in 8051 locations, and addition of these two and results will be stored in 8502 location. Okay, this is the result or sum should stored in, this is the program we need to write. So first what we have to write? So first instruction is move a comma, first we need to point out. So move dptr immediate data 8500H. We pointed to that particular location. So that is dptr is loaded with 8500H memory location. So that is means initializing a data pointer. Next, after this, what here the contents present in 8500 locations are 13. So we need to bring that 13 into accumulators. So therefore we need to write move a comma at the rate dptr. This instruction what will do? The contents of dptr point in location which is present represented by dptr is 5000. 8500. In that, the contents, what is the at the rate? ఈ మెమోరీ లొకేషన్స్ లో ఉండే కంటెంట్స్ అన్నట్లు అంటే 13 will be transferred to the accumulator. Then after this we have to retrieve another content which is present in 8051. So therefore again we need to bring into the accumulator only. So therefore before this accumulator consisting of 13, the 13 should send to the another memory location. So later I'll take r0 comma a. Now r0 lo emundi, r0 lo kuda 13 undi, accumulator lo kuda 13 undi. Okay, next after this we need to increment the data pointer, increment dptr. Now dptr points to 8501 location. So now what we need to bring the content of 8501 location into the accumulators. Therefore move a comma, sorry, this is external memory location. So therefore we need to put x, move x a comma at the rate dptr. dptr pointing to 8501. The contents of 8501 is moved to the accumulator. Next, accumulator here, accumulator consisting of 14. Now we need to perform addition, add a comma, another operand will present in or not register. So therefore move a comma or not. So again here addition will be performed here. 13 plus 14 which is equal to 27. This 27 will be stored in or not register, sorry, accumulator. Now accumulator, we need this data should send to the 8502 location. So result will be stored in 8502 location. This location, ఈ లొకేషన్ లకు పంపించాలి. అప్పుడు ఏం చేస్తాం మనం? ఇక్కడ move x, sorry, what is here data pointer is showing 8501 location only. So therefore we need to increase another, increment dptr. Now dptr points to 8502 location. So now we can send the data into this move x at the rate dptr comma a. The accumulator consisting of 27. This 27 is transferred to the data pointer location address. But the data pointer shows 8502 locations, and in that 8502 locations the result will be stored. So after this execution of this instruction, the result is 8502 location is updated as 27h. So after this, power stop as jump here. As jump here. The loop label here itself is a here only. Here it jumps continuously like this. So infinite loop. This is exactly equal to the end directive of 8051. And this is all about 8-bit numbers which are present in two external memory locations. We brought it into the accumulator and another registers. We perform addition and the result again stored in external location 8052. Third program is addition of 3 8-bit numbers. Addition of 3 8-bit numbers. Addition of 3 three 8-bit numbers. Here first, let us consider 0, 1, 0, 4 and 0, 7 or three 8-bit numbers. Directly, see we can write here itself. Here, let us take 8500 is there, where 01 data is there, 850104 is there, and 8502 the 07 is there, and result will be stored in 8503 itself. Here some should store. So for this we have to initialize the data pointer move dptr comma immediate address, that is 8500h. Next, this content should bring into accumulator. So therefore, where this data is present in external. So therefore, we have external memory. So we need to use MOVX to access the external memory locations. MOVX instruction will be used. This MOVX a comma @dptr. So that is at 8500 locations, the contents for 01 will be transferred to the accumulator. Next, again this move R0, the contents of accumulator is moved to the R0 register, and further increment dptr. Now again move x a comma @dptr. Again here this points to increment dptr means it points to 8501 locations where data 04 is there. That 04 will be moved to the again accumulator. Here R0 is 01, here accumulator is 04. So again we need to perform three additions, right? Addition on these two numbers. Again here after this instruction, I'll send this data to the another register. Move R1 comma A. So this 4 is transferred to the R1 register. Next again increment dptr. Next move x a comma @dptr. The contents of 8502 location dptr 07 is there, that is transferred to the accumulators. Now accumulator is updated with 07. After this, now accumulator R1 consisting of 04, accumulator consisting 07, and R0 is 01. So now what we'll do, we have to write add a comma R1, and this 07 and 04 will be added together. Okay. Next, the results will be updated in accumulator. And next instruction is, so another addition has to be carried out with a R0 registers. That is here. Where should I write this one? Add. Here after performing this addition, then second addition of there may be a chance of carry also. So therefore, we need to write instead of add, we need to write add C. So addition along with carry, the result will be stored in accumulator and R0. Here addition of contents A R0 plus carry. This why? Because initially we don't get any carry. So before carry in previous, if there is in previous operation, if the carry is there, see clear carry, to write a clear carry instruction. Carry is clear, and after these instructions a 3-bit addition will be performed here. Now again the after addition the result again stored in accumulator. So therefore now we have to send this result into 8503 locations. Therefore move x @dptr, the source contains or contains present in accumulator acting like a source. So this source will transfer to the destination with dptr, and destination address is 8503 location. Okay, sorry. Before this instruction, we have to write another instruction, that is increment dptr. Then only it points to the 8503 locations. Otherwise, it is pointing to 07. 07 లో ఏముంది 8502 లో 07 ఉంది కాబట్టి అక్కడ వరకే డేటా పాయింటర్ ఇంక్రీజ్ అయ్యింది. మనం ఇంక్రీజ్ చేస్తేనే ఈ లొకేషన్ కి మూవ్ అవుతుంది 8503. అక్కడికి వెళ్ళిన తర్వాత మనం ట్రాన్స్ఫర్ చేయొచ్చు. మూవ్ x@dptr, now here head. Otherwise, simply we can write like this. So immediate, by using immediate addressing mode, here move dptr immediate data 8500h. We initialize the data pointer. Directly I'm sending a data to the move a comma immediate data 01h. Okay. Next, add a comma, and second data is immediate, add a comma 04h. See here, observe, this is move a comma, just I'm moving here. Addition performed along with immediate data. Accumulator contents are 01 and immediate data is 04, and I'm performing addition of these two numbers, and result will be stored again in accumulators. Then third instruction is add c a comma immediate data again. Which one? 07h. And this 07h. Now 07, the contents of 0 here 01 plus 04 per addition will be performed. The result will be stored in accumulators, that is equal to 5. Here 05 plus 07, and along with carry plus carry. If there is a carry in a previous operations, then carry plus 5 plus 7. And these three addition, again result will be stored in accumulator. Now we need to transfer this data to the external. So therefore, external memory locations, move x@dptr, comma a. Why? Because accumulator is acting like a source now, where the result will be there, and that data we are sending to the external memory locations whose address is pointed by dptr. And next instruction is sjump here. Jump here. It's the end of the instruction. One is addition of two 16-bit numbers. Addition of two 16-bit numbers. Here, this is very important. Let us take 1, 2, 3, 4 is a 16-bit number. First 16-bit number. First one. And 3, 4, 5, 6 is another 6. 3, 4, 5, 1. Instead of 5, 6, consider only 5 and 3, 4, 5, 1 is another number, another 16 second and 16-bit numbers. So first here, the technique which is used is, first we need to send this data to the accumulator, and this is to the another accumulator data. And first we need to perform this addition, right? After this second, this first 16-bit number, this is called as lower LSD, lower significant digit. Okay, this is higher significant digit. This is a lower significant digit, higher significant number. Otherwise, this lower significant 8-bit number. This is lower significant 8-bit number of second 16-bit number, and this lower higher significant bit digit, lower and higher significant digit. Here sum will be performed of addition of this, and this sum plus this bits and this bit we added to the next like this. So now we'll start writing a program. Then I'll first. So definitely there is a carry from this. There is so many addition will be performed while performing a 2 16-bit numbers. So therefore definitely there is a possibility of carry. So we don't know what is the exact the position of carry before this writing exam. So therefore I am just clearing carry bit. Next, I have to send move a comma data is there na data. What data we need to send 34 in 34 into accumulator. And next I'll perform addition, immediate addition 34 add a comma immediate data. What is there next one? 51 inches. I'll perform 51 inches here. 51 inches completed. Next result will be stored in accumulator. So now what we need to do? We need to send this data to the external memory locations. Therefore, I need to initialize a pointer. Move dptr immediate data. Let us assume this is 8000 H. Next, what is the data which is what is the result which is present in accumulator? Has to send this 8000 locations. This is move x @dptr comma a. Now what we need to increase that increase data pointer. Why? Because to store another addition results, increment data pointer. Now again this is move a comma next higher significant digit of first to 16-bit number, that is immediate data, as 12H. Next add a comma another 34. 34 will be allow immediate data 34H into. Okay. These two will be added together, 12 and 34. See, 12 and 34 will be added, but before first addition there is a possibility of carry signal, so that's why and we need to keep add C a comma 34H, higher significant digit of next 16-bit number. Again addition of carry accumulator contains, that is 12 and 34. This is C place 12 place 30. Sorry, 34. 34 will be performed and result will be stored in accumulator. Now this data has to send external memory locations. Again, what we have to do here? This one. First increment, we need to increment the data pointer. Increment dptr. Right, data pointer is incremented. Sorry, already incremented, right? No need to write. No need to write. So already we wrote a incremented data pointer. Next, move x @dptr comma a. The data will be transferred to the here end instruction will be used, or sjump instruction used to create an infinite loop. Now next one is addition subtraction of 2 8-bit numbers. Yeah. So here write a program to subtract 2 8-bit numbers 23H and 14H and store the result in the location 8500. Here also very simple. First, what 23H is a one operand and 14H is another operand. See, program is first move a comma hash 23h. I transfer this immediate data to the accumulator. Next, I'll write directly sub b instruction a comma immediate data. What is the next immediate data? 14h. 14h. And before this instruction, we have to see here this is the addition operations. Subtraction operation. So definitely we need to clear a carry flag. Clear C. And see here a subtraction is performed, that is 23 minus 14h, and results will be stored in again accumulator. And so therefore now accumulator, so what he asked, the store the result in the location of 8500h. So we need to initialize the data pointer, move dptr immediate data, immediate address, that is 8500h. Now we have a data with the results in accumulator. Now accumulator data has to send to the 8500h location. So therefore external memory, we need to access the external memory. So therefore move x @dptr. dptr location is a destination and source is accumulator. So accumulator is stored. Next sjump here or stop. This is the instruction which is used. And next program is 8-bit subtract an 8-bit numbers from another 8-bit numbers and stored in memory locations. Here what he said is he didn't give a clear question actually. So how he explained is by writing a solution, we can say that even operands also present in external memory location, so we need to bring it back. So in second program, in subtraction second program, what happens is here 8500 is there, one operand, 8501 another operand is there, here 0203 let us see, and result will be stored in another address 8502 location. Here result has to store. So for this, but first of all we need to initialize data pointer, move dptr immediate address, that is 8500h. Now we need to bring the data which is present in 8500 into 500h into accumulator. So therefore move x a comma @dptr. One data is came into this one. So now this has to send to the one of the register, that is accumulator A. Otherwise accumulator la pettam anko malli increment data pointer malli move x @dptr anna anko malli override avutundi accumulator. So indulo na data ni first edo oka register laki pampistunnam. Next after that increment dptr. Now dptr points to 8501 location. Next I'll write move x a comma @dptr again. So now 03 is loaded into accumulator. Once the 03 is loaded into accumulator, say we have to perform subtraction. Before subtraction, a carry flag we need to clear C. So now accumulator contains our 03 and R2 contains our 02. Now we need to perform subtraction on these two numbers. So therefore sub b a comma R2. And again here subtraction of these two numbers 02 minus and 03, subtraction will be performed and result will be stored in again accumulator. Now accumulator here, so if there is a carry, borrow is there, so borrow is there, we need to move to jump, jump, otherwise see here this one 02 minus 03, see 02 is lesser and 03, so definitely carry will be created, carry will be generated here. So if carry is generated, what we need to is we have to perform 2's complement subtraction, 2's complement addition. Means 2's complement addition is same as subtraction only. Subtraction. అప్పుడు ఏం చేస్తాం, 2's complement అన్నాం అనుకో, ఈ రిజల్ట్ ని ఒకసారి కాంప్లిమెంట్ చేసి ఒకటి యాడ్ చేస్తాం అనుకో, 1 యాడ్ చేస్తాం అనుకో, ఇట్ బికమ్స్ 2's complement. సో అప్పుడు ఏం చేయాలి, ఇక్కడ we have to check condition, jump on no carry, jump on no carry to some this location. I will tell location down, jump on no carry to down లో ఏం రాస్తాం, no carry అన్నాం అనుకో, then result will be directly increment dptr is incremented data pointer. Next move, ఎక్కడ రిజల్ట్ ఉంది, అక్యుములేటర్ లో ఉంది రిజల్ట్. అప్పుడు ఏం చేయాలి, move x @dptr a and s jump here. ఒకవేళ మూవ్ డౌన్ ఈ కండిషన్ జంప్ ఆన్ నో క్యారీ అన్నాం, నో క్యారీ అయితే జంప్. ఒకవేళ క్యారీ వస్తే ఏం చేయాలి, క్యారీ వస్తే దెన్ we need to complement accumulator cpl accumulator, the contents of accumulators once complemented means once complement, then increment accumulator means we added 1 to the accumulators, complement added 1, so which results into 2's complement, right? Correct or not? So 2's complement, then again the result will be incremented dptr, move x @dptr a and s jump here. ఒకవేళ క్యారీ రాకపోతే ఈ రెండు చేయాల్సిన అవసరం లేదు, కాంప్లిమెంట్ అండ్ ఇంక్రిమెంట్ అక్యుములేటర్ చేయాల్సిన అవసరం లేదు. ఒకవేళ క్యారీ వచ్చింది అనుకో, కంపల్సరీ ఈ రెండు చేయాలి. ఎందుకు అని అంటే రిజల్ట్స్ విచ్ వి గోట్ ఇంటూ దిస్ ఎడిషన్, అంటే లోయర్ నంబర్ మైనస్ హయ్యర్ నంబర్ అన్నాం అనుకో, దెన్ డెఫినెట్లీ క్యారీ విల్ బి జనరేటెడ్. క్యారీ జనరేట్ అవుతుంది కాబట్టి మనం ఎడిషన్ ఎట్లా చేయాలంటే 2's complement లో చేయాలి. 2's complement అంటే ఇందులో ఉండే అక్యుములేటర్ డేటాని ఒకసారి కాంప్లిమెంట్ చేస్తే ఇట్ కన్వర్ట్స్ ఇంటూ 1's complement, ఇంక్రిమెంట్ చేస్తే ఇట్ యాడెడ్ 1 టు ది అక్యుములేటర్ కంటెంట్. సో దట్ మీన్స్ complement plus 1 is nothing but a 2's complement. This is 2's complement results will get exact results. So now 2's complement accumulator లో contents ఉంది, increment dptr and move x @dptr, అంటే 2's complement data will transfer to the 8502 location. Jump here, yes, jump here means end instruction. In last program is subtraction of two 16-bit numbers. Yeah. Let us take 1, 2, 3, 4. 5, 6, 2, 1. These two numbers are there. This is the first 16-bit number, and this is the second 16-bit number, and this 21 is the least significant digit of first 16-bit number. This is higher significant digit, least significant digit, higher significant. First we have to perform subtraction on these two numbers, after that these two numbers. So therefore first what we have to do, first see we I'll write a clear instruction, clear. Why? Because definitely there is a carry, there could be a carry. Why? Because arithmetic operation like a subtraction. So next, first we need to get the data, move a comma as immediate 21h into accumulator. Next, sub b, directly I'm writing sub b, accumulator content along with direct data. What is direct data? 34h. Here result will be stored in accumulators. Now we need to initialize a pointer. This data should be stored into external memory locations. Therefore, move dptr immediate data to, let us assume this is 2000h. So now I'm sending this initial list is subtraction of least significant digits on 2 by 16-bit numbers to this 2000 locations. So therefore, I need to use move x at the rate dptr. Okay. Next, I'm increasing data pointer, increment dptr, data pointer incremented. Next, move a comma higher significant digit of 56h. Next, I write subtraction sub b a comma a means 56h comma 12h. This is the immediate data 12h. 56 here. This itself considers a borrow also for a subtraction. No need to write like sub c, sub b, like sub add c ration sub c and instruction level. Sub b itself look after borrow. And next accumulator, the result will be stored in accumulators. Already we incremented a data pointer to a 2001 locations. Now move x at the rate dptr comma a. So now higher subtraction of higher significant digits of 216-bit numbers is moved to the 2001 location. Next, let's jump here. This is all about arithmetic programs in 8051. Arithmetic programs. I'll stop here. Next, I'll continue. In next class, I'll record after an hour. Why? Because I have an external duty. Today I'm going. These are very, very simple programs, and don't worry, it's very simple. And just practice once or twice, that's it, you will get it, all the problems. Don't worry, all the best.